Everything learned so far, resources, shared objects, caps, events, converges here. By the end of this lesson, you'll compile a marketplace where any user can buy a badge in one atomic transaction. The badge changes hands, the seller gets paid, and the protocol skims a fee, all without a central escrow key. Our singleton now tracks a flat key value table keyed by numeric listing IDs. We avoid nested vectors to simplify lookups and deletions. Price is denominated in SUI microcoins, Lamports. Fee-Tata BPS lets governance tweak protocol revenue without redeploying. All value transfers occur in one VM tick, so there's no escrow period. Either everything happens or nothing does. Deleting the listing row also refunds its storage slice to the buyer. An incentive for cleanup. Smart contract exploits often hide in race conditions. Shared object write locks block reentrancy, but sellers could still manipulate state between listing and buy. We therefore reread badge ownership inside the buy function. To frustrate ID snipers, we bump next ID before asserts, so even a failing attempt burns the ID and attackers can't shadow list. Fields are self-explanatory. Note listing lacks key. It's stored inside the table, not as a top-level object. Events will drive the web dashboard. Init now takes a treasury address so protocol revenue can route to a DEO or cold wallet. Helper functions centralize borrow global calls, reducing boilerplate. We transfer the badge into the shared object at 0x0, so ownership is indisputable. We store only its token, UID, not the whole resource to avoid nesting. Payment uses SUI's built-in coin, giant split to avoid manual math errors. We split out the fee, then the seller portion. Any dust change stays in pay coin and auto returns to the buyer when the TX finishes. Notice the sequence: verify badge, split fee, move funds, move badge, then emit event. If any assert fails, entire TX aborts. No half-paid situations. Only the original seller, checked via address, or a curator with a cap can cancel. The badge returns to the seller and storage rebate comes from removing the table row. Compute heavy? The coin splits add cost, but at today's 0.01 Swiss franc gas unit price, a purchase still lands under 1 cent. Because each write uses a unique ID key, two buyers of different listings run in parallel. Massive TPS. Your React app first pulls the table, then flips to WebSocket for live updates. Because the buy function deletes the listing, the front end removes the card after bought event. You already know the fee basis points, so you can show buyers a price breakdown before they sign.